I mean, you give an AI a massive task.
Right.
It gives you a result, and it looks great, beat, until you look closely.
Yeah, that is always the catch.
Suddenly, you are the bottleneck.
Yeah.
You are sitting there manually fixing endless, repetitive little mistakes. But what if the AI could actually police itself?
That concept completely shifts the automation paradigm. We are moving away from simple, one-shot text generation entirely.
Welcome to today's deep dive into the source material. We are exploring a fascinating system called the Gauntlet Loop.
It is a brilliant concept.
It is a specific workflow running inside Claude Code right now, and we will cover how it shifts AI from a one-shot generator to an automated assembly line.
Right, and that shift requires a totally new underlying architecture.
We are going to break down the exact 7-step workflow using Opus 5. We will examine real-world tests on 3D environments and websites.
Some of the results there are pretty wild.
They really are. And finally, we will reveal why this method can sometimes lead to insane resource costs.
Yeah, the token consumption on these loops can be genuinely staggering if you are not careful.
Let us start by unpacking the core friction of using AI for large projects, because we need to understand why a new prompting method is even necessary. Think about building a complex website or a game.
Something with a lot of moving parts.
Exactly. You write a highly detailed prompt. The AI gives you a fairly decent first draft.
But that output stops when it is just good enough.
Right.
It fundamentally lacks the cohesion required for a finished product. It leaves you, the human, to handle all the quality control.
You end up managing this exhausting feedback loop. You transition from being a creator to an editor.
Yeah, hunting down every hallucination, isolating broken code, writing another prompt hoping it fixes that one specific issue.
I have to admit, I still wrestle with prompt drift myself.
Oh, we all do.
Telling an AI to make it better usually just makes it confused. Beat, the original vision just gets lost.
The model literally loses the plot. The context window fills up and it starts guessing.
It feels exactly like being a tired manager.
Yeah.
You are micromanaging an eager but incredibly sloppy intern.
Yes. An intern who works fast but has zero contextual judgment. They fix the typo but accidentally delete the entire database.
So this brings us to the Gauntlet Loop. This is the solution.
It completely flips that standard workflow.
The new flow is build, review, fix, and repeat.
It automates the editing phase. It creates internal accountability.
And it requires 3 core parts to work. First, a clear task. Second, sub-agents and critic agents.
The division of labor is key here.
Let us define those terms quickly. Sub-agents are AI helpers focused on one tiny specific job.
Right.
And critic agents are AI checkers grading the work against strict rules.
So the sub-agent builds the component and the critic tries to break it. It is an adversarial loop.
The third part is a remarkably strict quality bar.
It literally cannot start generating until it hits that standard.
So who actually decides when this iterative work is finally done?
The internal critics measure the output against your initial quality bar. If it fails, the loop just runs again.
So the AI builds, grades, and fixes itself until it hits your exact standard.
Exactly. It carries the cognitive load entirely on its own.
Now that we understand the theory of self-correction, let us look under the hood.
This is where it gets really fun.
How do we actually program this behavior into Claude?
Well, specifically with Opus 5, you need a very precise template. You are programming a workflow, not just asking a question.
It is a strict 7-step workflow. Let us trace a prompt through it. Step 1 is planning and studying references.
The AI has to deeply understand the goal first. It creates an architectural plan before writing any code.
Step 2 is splitting the project. It assigns tasks to the subagents.
Right, to prevent the context window from getting overwhelmed.
Step 3 is setting strict rules. The subagents cannot change original requirements without technical reasons.
They cannot just hallucinate a new design because they felt like it.
Step 4 is the critic review.
The critics are programmed to be ruthless here. They check against the references, the functionality, the consistency.
Step 5 is the feedback loop itself.
But it only repeats if the proposed changes are meaningful. That stops it from infinite tweaking.
Step 6 is the final full project review. All parts are combined.
This integration step is huge.
It is like stacking Lego blocks of data. You have to see if the newly built car engine actually fits into the chassis.
Exactly. Because individual parts might look perfect on their own, but they fail catastrophically when combined.
And step 7 is the hard stop. It stops when requirements are met.
The output has to include the final result, a summary, and any unresolved limitations it could not fix.
Let me ask about that integration phase.
Yeah.
Why is the final integration check so absolutely vital here?
Because individual software components can be entirely flawless alone, but wiring them together often breaks the system.
Right. Perfect puzzle pieces still have to fit together to make the picture.
Exactly. The architecture has to remain intact. Sponsor. Insert provided sponsor read here.
We have built the engine. Now let us take it for a test drive.
Yeah, let us see it on complex projects.
Test 1 is a 3D apartment walkthrough. Claude gets a floor plan and room photos.
Translating 2D images into 3D space is massively complex.
The subagents build rooms. Critics check lighting, materials, and proportions.
The results were very revealing about the limits of this system.
The layout, the kitchen, the navigation, those worked well. But some textures and simple furniture still looked rough.
Right. It proves you need a strict quality bar. Subjective things like good lighting are just hard for critics to grade.
Whoa! Imagine an AI recursively fixing its own 3D lighting without you clicking a thing. 2-sec silence.
I know, the compounding potential there is staggering.
Test 2 was a product landing page. Claude uses brand materials to build a polished website.
This test was much more successful.
Critics check typography, responsive design, and content hierarchy.
The HTML and CSS were incredibly polished. Web code is structured, making it way easier to grade.
It was a highly polished UI, ready to use as a product concept.
Very consistent across the board.
What did the Gauntlet Loop specifically change in the website test versus a normal prompt?
It actively caught its own off-brand styling mistakes. It forced a complete revision before presenting the final draft.
It didn't just stop, it actively caught and fixed its own design mistake.
Exactly. It held itself accountable.
But the results sound a little too magical. Every automated system has a breaking point.
Oh, absolutely. There are major blind spots.
Where does the Gauntlet Loop fail?
Vague briefs. If your starting direction is vague, Claude will just endlessly polish the wrong idea.
And that leads to the massive resource drain.
The token consumption is insane.
One user ran a Gauntlet Loop for over a day. It generated 19,000 lines of code.
Every time the critic reads that growing code base, you pay for those tokens.
I have to push back here. Is spending insane tokens on 19,000 lines of code really better than just hiring a junior developer or fixing it yourself?
That is a very fair critique. It depends on your budget. Sometimes human intuition is faster and cheaper.
So when should we actually use this? Not for simple tasks.
No, use a normal prompt for that.
Oh, and not for rough ideas.
Generate the first draft manually.
So the ideal workflow is clear direction, first version, Gauntlet Loop for refinement, and then final human polish.
Yes. Deep structural refinement is where this shines.
When is this massive computational cost genuinely worth the price?
It is strictly for the refinement stage of complex, multi-part, highly structured systems.
Basically, don't use an automated sledgehammer to push in a simple thumbtack.
Right. Match the compute to the job.
Let us recap the big idea here. Eat. The Gauntlet Loop represents a massive shift. We're moving from AI as a simple question and answer bot to AI as an autonomous project manager.
It is a structural change in digital delegation.
By splitting tasks, grading its own work, and iterating, it saves human bandwidth. But only if you give it an airtight blueprint and strict stopping conditions.
You have to define success perfectly up front.
If we are handing over the critic role entirely to AI, what happens when our automated quality bar becomes so complex that we, the humans, can no longer verify if the AI critic actually made the right call? Beat. Something to think about next time you hit send on a massive prompt.
It is a slightly terrifying thought.
Thank you for joining us on this deep dive.